Okay, so this is going to be a bit of a different video. It's more of a video essay or blog. I'm going to be talking about why it would take a big player to save VR, but why that might not happen. So I want to start by looking at the history of VR, and I'm going to start with PC VR because that's really where it started this particular time, about 10 years ago. What we saw on PC were a bit of a wild west situation in VR with manufacturers concentrating on all sorts of different things. We had increases in resolution, changes in field of view, headset manufacturers pushing in different directions. There never seemed to be a final design on controllers. We're kind of getting there now, or headsets or feature sets even tracking was up for grabs, different methods there, and it became more like a hi-fi separates market in terms of headsets and accessories. You could really characterize PCVR as a kind of niche market, characterized by high cost. I mean, you came in with like the Valve Index being $1,000. Slightly fractured market in controller design, which probably hampered game development there. And we had Windows Mixed Reality coming in with lots of different headsets, but all broadly based on the same design. So that was an attempt at standardization. But then Microsoft abandoning it and leaving all those people high and dry. So things on PC kind of went in an arc, looking good, and then looking progressively more bleak. In the meantime, we saw the rise of the Meta takeover and the push towards standalone. They took their money away from PC and kind of pulled the PC store. We had, in order to make the compromise of losing the wire, we went to a smaller field of view with lower resolution. It made like a more console-like experience though, so game developers could optimize for that, but they were hampered a bit by the short life cycle of Meta's product releases, and then also starting from a pretty low bar in terms of power, with using, like the Quest 1 started with a fairly old mobile chip, but now they're pushing things further. We went to Quest 2 and now Quest 3, and as they push for more fidelity and clarity, you're falling foul of battery life as a compromise there. So hard to know whether they'll be able to push that further, much further, without the more fidelity you add, the hotter the thing gets, the more battery you need to run it, and the shorter that's likely to last. So we might have hit, I don't know if we've hit a wall there, but we may well be hitting a barrier there. And then you can look at the influence of Sony with their PSVR 1 and PSVR 2. It's a console again, so optimization of software is a possibility there. But then, as it's an accessory to the console, the base console of the PlayStation 4, then PlayStation 5, it's niche because it's an accessory and it's treated like a niche and not a boxed in product. And because of that, you've got limited first party support because it has to be, they're splitting their resources across the main console and this accessory. And then the problem is then whether you get the installed user base large enough to get the ball rolling for the developers to support it. And we certainly haven't reached a point where game developers are supporting VR by default. Definitely not. So only a limited number of developers are concentrating on VR specifically, and a small subset of developers who develop for consoles are producing versions that also support the PlayStation VR to accessory. So also there's like development hurdles converting flat games to VR, because there's a lack of controller scheme parity. The DualSense controller has more buttons than the Sense controllers, the VR Sense controllers, and of course there's the additional optimization you need to do in order to force render like your existing flat game into a stereoscopic VR. And also you need to implement dynamic foveated rendering to mitigate some of the graphical demands of rendering a stereo view that you need for VR that you don't need for displaying a flat game. On the positive side though, the PSVR 2 has pushed some bespoke technology into a unified feature set. So you've got eye tracking and dynamic foveated rendering, and headset haptics, and the high-end controllers with the decent haptics and the adjustable triggers. So that means that anyone developing for the Sony PSVR 2 knows that all the users will have access to all of those features, and so it's less fragmented than PC. But because it's a niche, then obviously there's a limited scope based on for making money based on the installed user base at the end of the day. So then we can look at Apple. So Apple just really recently joined the VR space with their Apple Vision Pro, supporting it with an OS which is sort of based on their tablet OS and at their own software level, but everything else they've kind of left to third parties. They've gone with eye and hand tracking together, which is like novel, but I would say far from perfect. But the interesting thing that they did do, as well as going extremely high end, was developing an entire chipset that helped the system to understand and render windows such that they fit in with the world. And what I mean by that is that they take into account the ambient lighting conditions of a room and try and make it look more like those windows and apps are part of the world in which you exist for mixed reality. So definitely a new player and obviously new methodologies and interfaces, but I still don't think they're quite there yet. And then you go back full circle to PC. So we've got a staged return of PC VR gaming. That's coming from enthusiastic mod scene where flat games are being modded and forced to work into VR, but normally, you know, the game isn't optimized for that, so you're really stuck in the high end to get that to work. And that's come about from things like the Unreal Engine VR mod and the Unity VR mods, which are sort of more universal injectors that allow you to play your flat games in VR. And that's good because it's sort of it's a step towards making a VR headset more like you just buying a different monitor and deciding to play the game on that, rather than having to have a special version of the game. But again, we've got a niche high-end headsets on PC, but really still no unified consistent feature set or guarantee of eye tracking on a particular headset, or so that you can enable dynamic foveated rendering and make it easier for lower end users to experience. And still support for dynamic foveated rendering is required on a per game basis. You have to enable it in the game engine rather than it being done at some higher level outside of the game. So rather than like it being an operating system feature, like you determine the resolution that you want to run the game at, and the game complying with that. You can't specify I would like to run this in full 3D virtual reality and then the game comply with that. It needs to be needs to be built into the game for that to work. Obviously, UEVR and UUVR are trying to get around that, and that is what they do. So I guess we're having a bit of a resurgence in PCVR because of that. But the popularity of like high end, it means that there's no middle ground. If you see what I mean, there's no way that you can have like a middle ground headset, because you're always going to be undercut by Meta with their headsets that can be used with PC. So it means that you've got some more fragmentation of the market. You've got the low end Meta headset with its limited feature set, meaning that people can't really come in with like a mid-range headset with more features, because as soon as you add more features, then you're going to end up in the expensive high end with low numbers, and therefore developers can't rely on those features being everywhere, ubiquitous. So having that low end headset compatible with PC is a double-edged sword, really, because it means that there's no like baseline. The baseline is always going to be the cheap headset and the one with the most users, and that is going to be a Meta one. So it's probably not going to pay developers to spend a lot of time optimizing for dynamic foveated rendering when the majority of people are going to be using a cheaper headset that doesn't have eye tracking. So, and it also means that other headset manufacturers really struggle to compete against a very subsidized Meta headset at the low end. And then the high end is populated by headsets that are very expensive but offer sort of diminishing returns in terms of perceived quality. So I mean, you have to spend a lot more money and get a bit more resolution. so okay, so that's basically looking over the history. So why do I think what's the future going to look like? I think it's all to play for, but I think you're going to need big money to be a player. So what might the future look like? What are the players? Who are the players? Okay, the players are like Apple, Sony, Meta, Google, and potentially Valve. They're the only companies really big enough that could consoleize a VR headset, so to get a consistent feature set. And I think you probably need that if you're going to try and capture the market, because everyone needs to kind of develop for a consistent set of features. I don't think it has to be a reductive set of features like Apple seem to have gone with. I think that the finger pinching, eye tracking input method is probably not the way to go for data input or interaction with anything that needs any kind of detail. I think they might be additional. Definitely, we've learnt that you can combine finger and eye tracking together, but I don't think it's going to be a replacement. I just don't think they're going to be fast or accurate enough to replace data entry. I think we just don't really use our eyes in the same way that we use other, more tactile parts of our bodies. I don't. When we're interacting with the computer, I'm typing this, but I can touch type. So when I was typing the script, I could touch type, but I can also like listen out and look away when I'm still interacting with the computer. So the concentration isn't necessarily need to be 100% on looking at every letter as I'm typing it. And so I think having the hand eye tracking method of input is just never going to be the most elegant way, or even the fastest way of doing things. So what I'm saying is that I think there is still room for controllers, or possibly utilizing computer vision as that technology improves, so that everyday objects could potentially become your input devices. So you could be using your favorite paintbrush or that particularly ergonomic Nerf gun to play your games with. Tracking could come from something stuck on, like a battery powered infrared constellation tracker, or a tracking puck, or even a simple sticker, which could be a two-dimensional barcode or fiducial marker that could be stuck onto anything, and then tracked by the inside out cameras on your headset. Or you could even have some kind of Internet of Things stick on set of battery operated mappable Bluetooth connected haptic buttons that you could then map to controls. So you could have your Nerf gun and put your stick on your Bluetooth mappable haptic button to the trigger and on the sides of it, and perhaps the magazine, and use those to be tracked and reload and understand when you pull the trigger, and make like bring physical objects into the game with you. It could be that Valve will bring their new track controller, which we've seen I think patents of, that seems to have button parity to a normal game controller, and that might make flat to VR game conversions simpler and give familiarity to people that are used to using that kind of controller. Then we can look at chipsets. So currently we've got Apple Silicon, we've got Meta embed with Qualcomm, and then Sony, or possibly Valve as well, because they've got the Steam Deck, embed with AMD. And while Sony did take advantage of some of the features that AMD could bring to the table, like using the USB DisplayPort connection, Apple showed that there's additional room there, and possibly a need for a bespoke VR chip solution that concentrates on raster and helps get that dynamic foveated rendering working at a kind of hardware level, so much faster hardware level. And I think it's probably that is going to be like a sticking point. You need a high degree of investment and good partnerships, and the guarantee of a large volume before you can really do a bespoke chip design. But I think that's probably what's needed in order to get to high resolution full field of view headsets that can push sufficient pixels to be convincing over the full human field of view. On PC, where the high end currently sits, I guess, we've seen that graphics has kind of stalled. First, by the pursuit of cryptocurrency, and then the focus on real-time ray tracing and machine learning for denoising, and then now the AI deep learning gold rush. And so that's the conflict of interest for the company Nvidia, and their high-end graphics cards aren't really pushing in the direction that you need to push as many pixels as we probably want for a high-end VR headset. Instead, they've made their bed trying to chase artificial intelligence, and understandably so, because there's so much money in it. They really do think that's going to be the disrupting tech, and so that's where they're pumping their dollars, understandably, for their returns, and they're doing incredibly well. So I can't really argue with that, but it's just doesn't suit the VR industry. So that's unfortunate that there seems to be a divergence there between our need for like high-end GPUs and their need to chase the AI market. And meanwhile, you've got their competitor AMD, which just seem to be following that same direction, and they're not even choosing to compete in high end this generation. Presumably because Nvidia have the mind share and market dominance, and they really don't think that people will buy their chip, even if they could potentially differentiate themselves by producing like a high-end GPU for VR. Right. Then you've got Qualcomm, and they obviously have their own XR chipsets, which are in Meta's headset. But I think there's still an opportunity for a company to differentiate themselves by producing a VR-focused discrete GPU. But it's going to need the backing of a big player in order to order a ton of them and fund that kind of development. So I do hope that a big player like Valve or Sony could push AMD in the direction of developing such a chipset for a future VR console, perhaps combined with a streaming to a wireless inside-out tracked headset. We'll see. As far as physical hardware goes, for VR you need advances in both optics and displays, and hopefully that will make wider field of view headsets possible with fewer distortions. We've already seen increases in brightness and contrast and resolution and clarity with micro OLED combined with pancake lenses, and maybe we'll see in the future even variations in focal length using multi-layered optics. But again, the power to handle a display like that relies on having GPUs to run them, and it seems like that's something that even high-end GPUs are struggling with at the current low fields of view. So we need something there. As for mixed reality, I guess gradually we'll get lower cost waveguides and smaller, lower powered projection technology that will make lower cost transparent displays over large fields of view possible in the future. They might be powered wirelessly of a sort of discrete off the face battery and compute combined puck, or maybe you would have a headset that just has transmitter and receiver and display on it, and could get maybe its compute from the cloud. So we'll wait and see what direction that goes in. Obviously that's going to be like signal dependent, and whether someone would actually want what is essentially a mobile phone taped to their head all the time. But now, okay, let's go on to why this VR feature might not happen. And some of it is just as simple as people don't like having things on their face. It's simple to say, but it's true. There are some people, well, there are whole industries devoted to making contact lenses, specifically for people who don't even want to wear a lightweight pair of glasses that they need to see. So you develop a need, you need to see, right? And there are whole industries that are devoted to just making contact lenses so people don't have to have anything on their face. So be that for aesthetic reasons, or just convenience, and not having to blink and clean them. So that's one reason the future of VR just may not ever happen, because there are just people that will not put things on their face at all. The second possible reason that the VR feature may not happen is because the market's too fragmented. It's too difficult to develop an app for a fragmented market. I mean, you've got in the case of mobile phones, you've really got two. Haven't you? Windows Phone went. So you've really got Android and iOS. That's it. So you're only ever actually developing for two. But for VR, you've got Meta and PC, and then all the other players like Sony. So you've got more. Basically there are more players, but then on PC you're kind of fragmented further because you can't really develop for multiple headsets. So it's difficult to develop for a fragmented market, and especially when it's also niche. So yeah, so you've got Apple separate from everyone, Sony separate from PC, and then PC separate from Quest. So if you want to hit all users, you have to port everything everywhere, and that's probably too many fragmented in a market. The market's too fragmented, so it might be that it never becomes mass adopted because it's currently too fragmented, and we need to get down to 1 or 2 players. There's another reason why the future of the VR that we want might not happen is because the scale of the investment is so high. So that's fine if you're piggybacking off someone else's tech, but I think now we've seen that GPU is moving away from what we would need for VR. So you can no longer sort of piggyback off their developments, and also they're not being competed with by anyone, so they can price gouge. So that makes it even more difficult for getting mass adoption because it's just super expensive. So we've seen the GPU market chase the money, and the money isn't in VR at the moment, it's in AI. So there just won't be the compute power we need to run a full field of view headset on current gen hardware, and it looks like the graphics tech is going in a different direction than we want. Okay, another reason why VR might not get the future that we want is because the everyman is becoming poorer and the tech is getting more and more expensive. The economy is, if the economy divides even further, then who is the consumer going to be? Can VR be the entertainment of the masses if it's too expensive for mass adoption now, and people aren't getting richer because the distribution of wealth is becoming more and more skewed? So if people are getting poorer, how are they going to afford affordable VR? All right, and if they're not buying it in the droves now, how are you going to get the economies of scale? All right. So yeah, I go on to the next bit because the tech's high end and low yield, and the economy of scale isn't there to make it cheap. So we can look at this. When Meta pushed the Quest Pro and Quest 3, who did they think they were selling that to? Did they think adults were going to buy it? But why? What were they going to use it for? And then now you've got it, Quest 3 being outsold by Quest 3S. It's probably because the market just won't tolerate that high price of entry for something they deem as frivolous or throwaway. The market will tolerate high prices for something they deem indispensable, like the jack of all trades mobile smartphone. People will pay a lot a month for that because they deem it indispensable. It's everything. It's their entertainment, it's their communication, it's their their companion. But VR headsets aren't filling that void yet. Another reason we might not get the VR feature we'll want is because maybe the device is small and light enough to be acceptable to wear on your face, just won't be powerful enough or have a sufficient battery life to make them usable. And that's definitely the case now, I think. The battery demand on Vision Pro and Quest 3 is where I'm sort of pointing this at. Battery life measured in hours isn't going to cut it for an indispensable device, is it? And it's hard to make a non-portable device indispensable unless you're going to have one at home and also on the way and also when you get there, at your office. So if it's not going to be portable, you need to have more than one. And if it's expensive and has a short battery life, I don't know how that fits. I don't know how that fits in for the wireless versions of the VR feature. If it needs to be light enough to wear, it needs to have battery life to be constantly wearable. And finally, it's just not easier to use. So as I wrote the script for this, I realised how much more difficult it would be to do all of that in VR. Everything I'm doing here to do in VR is not easier than the way I did this by writing it into a word processor on a computer using a keyboard. Um, and that's really the problem to solve, isn't it? It's just not easier and more productive to use VR yet. So I mean, there are YouTubers that do have YouTube channels in VR, and they had to build their own studios, and then presume their own auto cues, and they had to program them themselves. Typing in VR is nightmarish. So whether that's on an unseen keyboard because you just can't see it because you have no pass through, or having to set up your own pass through keyboard, or having a wobbly pass through keyboard that you would on Quest 3, or looking and pinching every single letter to type anything, yeah. So I've been in VR for 10 years. I wouldn't know how to even begin to make this whole process, recording this video, typing the script and filming it in VR. I wouldn't know how to begin with that. So it's certainly not easier to do what I'm doing now in VR. Where's the app for it? Where's the word processor app for it on VR? Anyway, so yes, that's really where I've come down to then. So yes, going through the history, looking at possible future and why it may or may not happen. We'll wait and see. Obviously it's still exciting to be in VR and part of the VR scene. I really enjoy playing my games in VR. I think it's the most immersive way to play. I'm impatient for the future, but I'm concerned that we might not get there. We're going to have to wait a few more years. Still a few more years. Alright, that's all I've got for this video. I hope to catch you again. Let me know in the comments if you like this kind of blog video essay, and what you think will be the future of VR. So I'll catch you all in the next one. Remember to like and subscribe. That's all I've got for you this video. Bye bye.